Hello, this is Mr. Best. Welcome to section 4.3, Right Triangle Trigonometry, Part 1. We're going to look at acute angles of trig functions, and we're also going to evaluate trig functions using a calculator. First thing is, with a right triangle, one of the things that you guys will remember is the Pythagorean theorem, where you take one leg squared plus another leg squared, and it's equal to the hypotenuse squared. From a right triangle and the three sides, there are 6 ratios. And those 6 ratios would be A over B, A over C, B over A, B over C, C over A, and C over B. So there's 6 ratios for all right triangles. And each one of those ratios represents one of our trigonometric functions. The first ratio we will look at will be side B over side C. So from theta, side B represents opposite, C is the hypotenuse. So the ratio that's opposite of the angle and the hypotenuse is called sine. It's spelled, abbreviated, S-I-N, but it's pronounced sine, spelled S-I-N-E. So sine of an angle theta is equal to opposite over hypotenuse. Another ratio is A over C. A represents the adjacent over hypotenuse. And once again, that's pronounced cosine, but spelled, abbreviated, C-O-S. And that's cosine of theta is equal to adjacent over hypotenuse. Tangent is B over A, pronounced tangent, spelled T-A-N, abbreviated, theta. So tan of theta, that's tangent of theta is equal to B over A. B is the opposite side over the adjacent side. These are our 3 main trig functions. We will then take the reciprocal of these 3. So cosecant, abbreviated CSC. So cosecant of theta, instead of being B over C, is C, is the reciprocal of sine. So that's C over B, which is hypotenuse over opposite. Secant, abbreviated SEC of theta, is the reciprocal of cosine. So that's C over A, which is equal to the hypotenuse over the adjacent side. And cotangent, abbreviated COT, cotangent of theta, is the reciprocal of tangent, so that's A over B, and that is adjacent over opposite. So those are your 6 ratios of a right triangle. One of the ways to remember this is SOHCAHTOA. SOH is sine, and then OH is opposite over hypotenuse. C is for cosine, A is for adjacent, H is for hypotenuse, so adjacent over hypotenuse, and then TOA, tangent, is equal to opposite over adjacent. So that's just one way to help you remember the 6 trig ratios. First example, given a right triangle with side lengths 6 and 10, find the exact value of the 6 trigonometric functions. So you're finding the 6 ratios, which means you need to know what the 3 side lengths are. So to find the other leg, you take your hypotenuse and square it, and that's equal to the opposite side squared plus the adjacent side squared. And you solve the equation for B. And you get B squared is equal to 64, so B is equal to 8. Now that you have all 3 side lengths, you can find the 6 ratios. 6 represents the adjacent side, 8 is the opposite, and 10 represents the hypotenuse across from the right angle. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And then I just reduce those values. Cosecant's the reciprocal of sine. Secant's the reciprocal of cosine. And cotangent is the reciprocal of tangent. And so those are the 6 ratios for the right triangle. The second example here wants you to sketch a right triangle and then find the exact value of the remaining trig functions if you're given 1. Now tangent of theta is equal to 4 over 1. So if it gives you 4 over 1, remember that would be opposite over adjacent. So you actually have 2 of the side lengths of a right triangle. So there's your right triangle. Put theta in either acute angle, and then you have opposite over adjacent. Not drawn to scale, but that's opposite over adjacent. Now you can use Pythagorean theorem to find the hypotenuse. So that'd be 1 squared plus 4 squared is equal to c squared. So 1 plus 16. So 17 is equal to c squared. So c is equal to the square root of 17. So now once again, just like on the last one, you have all 3 side lengths. So now you can find the 6 trig ratios. So once again, the 6 trig ratios would be sine of theta would be opposite 4 over the square root of 17. If you multiply top and bottom by the square root of 17, we're going to rationalize the denominator. So that's 4 square root of 17 over 17. Cosine is adjacent, 1 over the square root of 17. And if you rationalize that, that would be the square root of 17 over 17. Tangent was given, that's 4, but it's opposite over adjacent. And then cosecant's the reciprocal. So that's square root of 17 over 4. Don't have to rationalize it because it's on top. Same thing with secant. It's the reciprocal of cosine. That's the square root of 17 over 1. And then cotangent's the reciprocal of tangent, which is 1/4. So once again, similar to example 1, but you have to create the triangle from given 1 trig function. We're going to start looking at 3 very specific trig ratios of 3 different angles. We're going to look at 45, 30, and 60. We'll start with the 45. Given a 45, 45, 90 triangle, let's say that the side lengths of that triangle are both 1, since they are across from the same angle, so their lengths would be the same. And if you did Pythagorean theorem, that would be 1 squared plus 1 squared is equal to the hypotenuse squared. So that's 2 is equal to c squared, so c is equal to the square root of 2. And it doesn't matter what the side lengths are of a 45, 45, 90. The ratios will always be the same. So now what's sine of 45? Well, that would be opposite 1 over the square root of 2, which simplifies to the square root of 2 over 2. Once again, sine of 45, no matter what right triangle you're looking at, will always have the ratio square root of 2 over 2. Cosine of 45 is 1 over the square root of 2 also, which is square root of 2 over 2. Tangent of 45 is 1 over 1, which is just 1. And then you'll do the reciprocal of sine to get cosecant of 45, that's the square root of 2. Secant of 45 is the reciprocal of cosine, which is square root of 2. And then cotangent of 45 is reciprocal of 1, which is 1. So those 6 ratios for a 45-degree angle are going to be very important as we progress through the rest of this unit. Now let's take a look at the 30-60 triangle. We have taken an equilateral triangle here where all the angles are 60 degrees. And we split it in half, so now we know that this angle up here is 30 degrees. If we say that the side lengths of the equilateral triangle are 2, then we know when we cut it in half we have a length of 1, and we can now find the other leg by doing 1 squared plus that leg squared is equal to the hypotenuse squared. So 1 plus b squared is equal to 4. Subtract the 1. And we get b squared is equal to 3, so b is equal to the square root of 3. So the long leg is the square root of 3. So now we're going to go through and find the 6 ratios for 30 degrees and 60 degrees. So sine of 30, I'll just look at this angle right here. Sine of 30 is opposite over hypotenuse, so that's 1 over 2. Cosine is adjacent over hypotenuse, square root of 3 over 2. And tangent of 30 is going to be opposite over adjacent, which is 1 over the square root of 3 or square root of 3 over 3. And then to do cosecant of 30 is reciprocal of sine. Secant of 30 is reciprocal of cosine, so that's 2 over the square root of 3, which rationalizes to 2 square roots of 3 over 3. And then cotangent of 30 is reciprocal of tangent, which is the square root of 3. So now we'll look at the 60-degree angle and do the 6 again. So sine of 60 is opposite, which would be square root of 3 over hypotenuse. Cosine of 60 is adjacent over hypotenuse. Tangent of 60 is opposite, so that'd be square root of 3 over adjacent 1, so that's just the square root of 3. And then reciprocal of each of these, so it'd be 2 over the square root of 3, which would be 2 square roots of 3 over 3. Secant of 60 is reciprocal of cosine of 60, so that'd be 2. And cotangent is the reciprocal of tangent, so that's square root of 3 over 3. So now we have looked at 30, 45, and 60 degree angles and the 6 trig ratios that go with them. You're going to see a lot of similar angles with the 30 and 60 because you're using the same triangle. So if we're looking for the exact value of tangent of 30, you can set up that triangle that gives you a 30, 60, 90, and you can say 2 is the hypotenuse, the short leg is 1, the long leg is the square root of 3. So tangent of 30 is opposite over adjacent, so that would be square root of 3 over 3. And there's your ratio. Sine of 60, we can use the same triangle. Sine would be opposite over hypotenuse, so it'd be square root of 3 over 2. And then secant of 45 is the reciprocal of cosine. So cosine of 45, if we get our 45 in here, 1, 1, and the square root of 2. So cosine would be adjacent 1 over the square root of 2. So secant's the reciprocal of that, that'd be square root of 2 over 1. And so that's just the square root of 2. So you're able to find any of the 30, 45, 60 trig functions using right triangles. The last thing that we're going to be doing is using a calculator to approximate trig functions. We're going to round to 4 places. On cosine of 38 degrees, before you type that in your calculator, you want to go to mode on your calculator, and you'll see that first screenshot there, and go down and make sure you're in degrees. Once you're in degrees, just press cosine 38 and then hit enter. And if we round to 4 places, that would be 0.7880. So that's the ratio for a right triangle with an angle of 38 degrees. Cosine is adjacent over hypotenuse. That would be that ratio. For cosecant of pi over 12, since now we're in radians, you want to go back to that mode screen and now make sure you are in radians. Once you know you're in radians, cosecant is the reciprocal of sine, so I'm going to do 1 divided by sine of pi over 12, because cosecant is the reciprocal of your sine, so that would be the ratio 3.8637. And then on example number 6, once again we're in radians still, so do tangent of pi divided by 8, make sure it's in parentheses, so you're taking tangent of that angle, and we get 0.4142. So that's how you use the calculator to approximate your trig functions. It's very important that you remember what mode you're in, or to check to make sure if you're doing degrees, you're in degrees. If you're doing radians, you're in radians.